Unit 5 of the Magento 2 Fundamentals course contains 5 modules. The suggested flow of the course is indicated by the arrows. However, you are free to access any of the modules at any time by simply clicking the Home button on the bottom of each slide. The topic of this module is service contracts. There are several important concepts that have been incorporated into Magento 2, such as plugins, dependency injection, and service contracts. These demonstrate that overall, the changes in going from Magento 1 to Magento 2 are focused more on the way you do things, to be more flexible and efficient, rather than introducing new features. In this module, we will provide an overview of service contracts, focusing on the benefits of using service contracts, how they are implemented in Magento 2, and how you can customize Magento 2 using a service-based approach. Service contracts fulfill a number of important functions, such as improving the upgrade process, formalizing the customization process, and decoupling modules. We will look at each of these concepts in turn within this section. Basically, service contracts are a set of interfaces that are available for modules to declare standard APIs. A service layer is used for making customizations without having to delve deeper into the product core. They also help with module interoperability. This is possible because the implementation of an interface might change, but the signature will not. Service contracts are also designed to make the customization process more formal and straightforward, helping to minimize situations where you have to hunt for classes and haphazardly make changes that might fulfill one function but break others. Now, all classes are documented via their interfaces so that you know exactly what each does and how using it will impact your entire implementation. The way developers now work with Magento is quite different. When you do something, you no longer need to rely on the implementation, but on public methods and parameters declared in interfaces. All modules are built to rely on interfaces. Decoupling modules used to be quite difficult in Magento 1, especially the larger and more complex modules like tax and customer. Now, with the use of interfaces and APIs, it is much clearer how to interact with modules in Magento's more modular system. The diagram depicts a theoretical structure of APIs within Magento 2. Operations can be divided between two groups, data and operational. These terms are not formal, but are used to give you a better idea of how the various Magento 2 APIs are segregated. The Data API provides access to a module's entity data. The Data API can be found in the folder Module Name, API, Data. The Operational API not only provides data, but also drives the actual operations used on that data. These APIs allow business operations to function properly between modules. This API usually includes the public methods of Magento 1, models and helpers. So, the Data API only exposes create, read, update, delete methods, while the Operational API actually does something. The operational APIs for a module can be found in the folder Module Name, API, except for Data, which is located in a subfolder. In Magento 1, when you wanted to customize a module, you had to read the core code. You had to understand how it worked in order to be able to create the required change. In Magento 2, you can now customize a module using an API interface that communicates with the model without interacting directly with the core, a much safer approach. What are some of the benefits of using a services approach? It provides comprehensive internal documentation that allows you to make customizations without having to go into the core. Following this approach helps to minimize conflicts between modules. Magento upgrades are much safer to execute without anything breaking. Clear extension points make customizations easier. There are also some drawbacks to using a services approach of which you should be aware. Services often will either be too simple or too complex, too broad or too granular. It will be more difficult to perform low-level, refined customizations. The approach may work differently with different implementations. It may be more difficult to debug an application using this approach. Also, you need to assess whether the changes you propose to make are compatible with interfaces, as opposed to directly changing classes in Magento 1. Now that we are finished with the overview, we're going to look more closely at the types of Magento 2 APIs, starting with the Framework API. In this module, we will discuss the Framework API component, repositories, and the Business Logic API. API Review 1. What is the function of an API in Magento 2? An API is a possible point of customization only. An API facilitates SOAP and REST only. An API provides a structured form of communication between modules. API Review 2. Which three of the following options describe the structure of Magento 2 API components? Product API, Repository, Business API, Data API, Catalog API. API Review 3. For which of the following tasks would you use an API rather than a Magento 1 type object, like a collection? To fetch a list of objects from a database, to join a core table with a custom table, to save or delete an object. In this diagram, we have separated the operational API into more detailed components, specifically the Business Logic API and repositories. The Data API and the Framework API remain their own logical units. Repositories provide the equivalent of service-level collections, while the Business Logic API provides the actual business operations. The Framework API provides interfaces, implementations, and classes for various parts. Here is an example of a Business Logic API for the Magento catalog. The code provides an example of implementing the Business Logic API using the Magento Customer API Account Management Interface. To see an example for a concrete implementation, search for the public function Magento Customer Model Account Management Authenticate in the app installation. An example of a repository interface and its implementation. One important part of the operational API is repositories. Typically, a repository is an interface that provides access to a set of objects using the getList method. It has no obligation to extend something from Framework. However, repository getList methods typically receive an instance of the search criteria interface defined as part of the framework. The framework also supplies an implementation for that interface, namely Magento Framework API Search Criteria. We will discuss search criteria in more detail later in the course. As the diagram shows, the Data API implementation may extend abstract extensible objects, but it is also possible for Data API implementations to extend other classes or nothing at all. Business Logic API implementations usually extend nothing. Repositories usually extend nothing, but expect a search criteria interface implementation as the parameter to their getList method. Abstract Simple Object is a class that is similar in concept to the variant object in Magento 1. It also has a data property, but it does not provide magic getters and setters. It only provides protected setData and get methods, as you'll see in the following code example. This class is useful to extend if some data needs to be configurable via DIXML. The object factory will inject the data array as a constructor argument. Abstract Simple Object provides the get method, which returns an item from the data array, or null if the requested key doesn't exist. The important takeaway point is that this object does not provide public getters and setters. They need to be implemented as required by the concrete implementation extending Abstract Simple Object. General process. You extend the Abstract Simple Object builder, optionally adding methods to specify the data that is required to instantiate the simple object. Then, you create an instance of your builder and send the data to the builder. The builder then takes the data and injects it into the simple object when the method create is called. This process reflects not having public methods. Simple Builder interface has two methods, create and getData. These are implemented mainly by the Abstract Simple Object Builder. Within the Abstract Simple Object Builder create method, the data array is passed to the object factory to be injected into the data object during instantiation. Highlighted text line. You can see from the code of the method getDataObjectType that the simple object type is the class name of the builder without the word builder attached at the end. Now that we have finished our general discussion of the Framework API, we are going to look at the API in more detail, focused on repositories and the Business Logic API. In this module, we will discuss in detail repositories, search criteria, and Business Logic API. Repositories provide access to data sources, acting as a type of intermediary. The advantage to using this design pattern and its service API is that your application can function independent of the number of data sources and how they are connected to the app. This allows for easier upgrades. And since repositories deal with data objects and not models, the structure is compatible with any object relational mapping system. So for example, if you were to expand the product line of a store, in theory you could add data sources without having to modify the application itself. Only the repository would have to know about the new sources. This diagram depicts a repository accessing the database through a resource model and a collection. This chart presents a high-level comparison between repositories and collections, highlighting some of the facts we have already discussed. As repositories are services, they will remain unchanged with new releases, making upgrades easier. That is not true of collections. Repositories deal with instances of data objects, not models. Repositories use search criteria for filtering and sorting data, while collections use a method interface that can be customized down to very low levels. Almost all repositories have a getList method, which accepts a search criteria instance as part of its signature. Collections provide low-level access to select objects, which allow for custom queries. Here is a code example of a repository. The Customer Repository Interface. As you can see, the Customer Repository Interface is composed of a number of public methods, highlighted text, which all deal with the persistence layer. The parameters are Magento Customer Model Data Customer Instances, not to be confused with regular customer models, Magento Customer Model Customer. In looking at the get function, you will notice the customer registry object. In contrast to one large registry in Magento 1, Magento 2 has a number of smaller registries. If you call get with the same arguments 2 times, it will return the same instance. This is an example of the identity map design pattern. Here you see that the registry uses the customer ID. This flow diagram is an illustration of the code we just examined on the previous slide. This code example displays part of the customer repository GetList implementation. Not all lines of code of the original method are included, but it shows how the search criteria instance is used to set filters on the collection, and how the loaded collection is used to populate the search result instance. This diagram illustrates what we just looked at in the code example, that sets of filters, predefined and from the search criteria, are added to the collection. This additional diagram focuses on the save method within the repository and the corresponding classes involved. Search criteria is the parameter in a repository's getList method, which defines filters, sorting, and paging. Looking at the code above, you can see how the search criteria instance is created using Search Criteria Builder. First, all filters are added to the builder, and then the search criteria object is instantiated using the builder's create method. Search criteria implements the search criteria interface and extends the class AbstractSimpleObject. It uses the set of filters contained within search filter group, which in turn wraps filter instances. Search criteria builder, extending AbstractSimpleObject, is used to create the search criteria object. Here is a list of the public methods available within the search criteria interface. We're going to look at the search criteria components and values in more detail. Filter groups, filters, sort order, sorts, page size, limits, current page, offsets. Here is a list of Search Criteria Builder methods that access the data array inherited from AbstractSimpleObject Builder. As you can see, this is not very complex code. It just takes an array and sets it on the inherited data array. Please note that usually the manipulators for the search criteria are not used. According to best practices, all properties should be set on the search criteria builder, which in turn injects the complete data array during instantiation. Once the search criteria has been instantiated in this way, only getters should be used on it. The filter class extends AbstractSimpleObject and adds the methods getSetField, getSetValue, and getSetConditionType. Just as with search criteria, even though the class exposes setters, it will usually be constructed using the filter builder, which injects all values during instantiation. This is the filter builder code, which is used to create instances of the filter class shown on the previous slide. In the previous 2 slides, we saw a high-level illustration and then a code example of filters and filter builders. This diagram demonstrates the relationship between filter group and filter group builder. The builder extends the AbstractSimpleObject builder, while the filter group extends the AbstractSimpleObject. Filters the group should include are set on the filter group builder using the setFilter method, and then the filter group is instantiated as usual using the builder's create method. This diagram demonstrates the relationship between sort order and sort order builder. Sort order builder creates the sort order after the fields and directions are specified using the methods setField and setDirection. The builder also extends the abstract simple object builder, while sort order extends the abstract simple object. As its name implies, search results is an object that represents search results. It is the base interface returned from repository getList methods. This code example lists the public methods of the search results interface. In the Service Contracts Overview module, we discussed how the Framework API could be thought of as composed of two related APIs, the Data API and the Operational API. In the following module, we then looked at these components in more detail, dividing the operational functions into repositories and a Business Logic API. We are now going to look at the Business Logic API in more detail. This overview diagram illustrates how the elements that compose the theoretical API relate to a module. The Business Logic API contains all the logic not contained within repositories or the Data API, and is responsible basically for all the actions a module can take. In the Business Logic part of a module, you have unique features such as sending an email, selecting a product, and placing an order. Here are some examples of the Business Logic API contained in the Customer module: validate, authenticate, resend a confirmation, and more. Here is an example from the Account Management implementation: resending a confirmation email. As usual with an implementation, we have an interface that specifies the method signatures. In some cases, it will be specialized classes that implement the interface. Otherwise, it is a regular Magento model. See your course Exercises Guide for instructions on how to complete this exercise and its solution. We will now shift our focus to examining the Data API, the remaining aspect of the Framework API. In this module, we will discuss the Data API Overview, Extensible Objects. Note that APIs are used both within and outside of Magento. Every module has an API folder that is available to the outside by calling it through a web service like SOAP or REST. This aspect will be examined in the next final module. As we have discussed earlier, we want our models to have an API, and we want to be able to very clearly specify which data is passed in and out this way. How do we define the type of data? The solution is the Data API. Data objects are essentially a set of fields defined by an interface that allow us to describe the type of data to use. The Data API defines the getters and setters for each of these fields. Secondly, we need some flexibility to define new attributes, provide information about relationships, and so on. The Data API is designed to meet this need by allowing the assignment of custom attributes. This may seem somewhat of a contradiction. We want the API to offer flexibility, yet we also want it to provide a well-defined structure for interacting with services like SOAP. We will examine both aspects in this module. How do you implement the Data API? We already know that there is a Data API folder that contains The customer repository is an example of the implementation of data objects. In the product repository example, you see that the service layer API directly returns the product models. Both approaches generally use search result interface. The diagram shows the components involved in extending an interface: the sequence extensible object, extension attributes, and metadata object. We will look at each in turn. Important. In Magento, you can easily extend objects, but you cannot directly change interfaces. Instead, you change the interface's implementation using specific extensibility techniques. For example, using a plugin will change the implementation, not the interface itself. The extensible data interface only contains a constant used as the data array key for an extension attributes object. The custom data interface also contains a key. This one is for custom attributes. This diagram provides more detail on the extensible object diagram 3 slides earlier. Abstract extensible object will take a parameter of extension attributes factory or attribute value factory via dependency injection. When you create an implementation of that interface, it extends its own extensible object with its own custom logic. If you want to have some objects in your method, you would have to use or alter a constructor. This all gets a little more complex when you add an interface to the model. So instead, specify the custom attributes using the getters and setters defined in the abstract extensible object. This diagram depicts how you add custom attributes versus extension attributes. You set custom attributes using the attribute value factory, which provides an attribute interface. Then, with this interface, you can set the code and the values you want. Every EAV interface implementation will have its own metadata object. The metadata object is an analog of the EAV config class in Magento 1, which provided information on attributes, classes, entities, and more. We've already discussed how get-set extension attributes function in the overall workflow of extensible objects. The code here demonstrates how to set an extension attributes object. This is very straightforward. The interface customer, model, data, customer implements the customer data API interface, which defines attributes as constants. In this customer interface example, we can see a list of the possible constants defined for a data array. We will now look at configuration. The configuration file that will accept your object with extension attributes is extensionattributes.xml. A good example of an extension attribute is a stock item for a product. Every product has a stock item, and every stock item is another entity, another set of tables. The stock item is an extension attribute. If you request the stock item from a product object, you will get an extension object, and that object will contain the stock item data. This code example demonstrates how a stock item for a product is loaded onto a product. You declare your extension object in the XML, and then you create a plugin to populate it. Typically, to accomplish this, you would need a product extension factory. This factory is generated by the XML and will provide the ability to add a new stock item. Now, if you call an extension, you would get the extension attributes. This will then allow you to use a get method to retrieve the stock item since the configuration has been set. If you do not set the configuration identifying the type, the get process will fail. Within the extension XML, there is a join feature that you can use to join tables if it is of simple type. There are no native examples, and not every repository currently supports the join functionality. See your course Exercises Guide for instructions on how to complete this exercise and its solution. Our final topic is the Web API of Magento 2. In this module, we will discuss the Web API, SOAP Web Service, and REST Web Service. Within Magento 2, the Web API allows exposure of the Module API service contract. In Magento 2, every repository and API can easily be available through the Web API. With Magento 2's very strict definitions of all the classes, all the included parameters, and all the return values, it is now possible to generate XML that easily makes the Service Layer API available through the web. Note that it is a little easier to do with REST because it is not very strict, less strict than SOAP. With the strict definitions of methods and their parameters, and because every object passed through the Service Layer API is now a data object, it is relatively easy to convert the data into arrays back and forth. So, you create an array of data and send it to SOAP, for example. It will understand it, execute the method, and create a data object for use with a setter. It will execute the appropriate method and get back a data object which it can convert to an array. The diagram above shows the process in more detail. You have two protocol choices to make a repository available, SOAP or REST. For the REST API, you have to declare a URL on which your API will be available using webapi.xml. Also in this file, you need to specify the required interfaces, available services, and methods for the APIs. With these interfaces included, you can use the generic SOAP API. Then, the implementation is taken from the .xml file, which calls the method. Magento 2 has what is called a Web API area. So when a Web API call occurs, data from the folder Web API REST or Web API SOAP will be used. These folders usually contain specific di.xml files. This diagram represents the structure of the Web API XML file. The root node of the Web API.xml file is the routes node. Each route defines a URL. A service defines a class interface and method, and a resource defines the ACL. Here is an example of a Web API XML file from the customer module. The route contains the URL and a method like get, post, or delete. The service defines the interface and the method that will handle the URL. The resource defines a list of ACL resources for Web API, in this case, Magento Customer Group. There are now three types of resources available for the Web API ACL, which is a significant change from Magento 1, which had an ACL for admin and an ACL for API. The Magento 2 ACL options are Self, Anonymous, Magento ACL Resources. Magento ACL is part of the admin resources and therefore requires admin permissions. Anonymous applies to anyone. Self is mainly available for customer data. There are three types of authentication: OAuth for SOAP, token-based for REST, and session-based. OAuth needs to be used with SOAP service authentication. REST uses a token-based process, as we will see shortly. A SOAP authentication requires an integration with an access token that has to be created in the Admin System Integration menu. Here is a screenshot of the page where you would set up the new integration. Then, on the Integration Details section, you would set the access token. You can also specify what resources you would like to make available for each API. WSDL is generated automatically based on your services. The diagram above shows a WSDL structure. You go to Magento Host, and then with SOAP WSDL Services, you can define a list of services. Module Interface v1, Module 2 Interface v1 specifies the version. There are rules as to how you specify the WSDL URL. Here is the rule: Module Interface Version, and the example is shown above, Catalog Product Repository v1. This diagram illustrates the conversion of a method call to specify a WSDL URL. This code provides an example of how to specify the required authorization header for SOAP, highlighted text. See your course exercises guide for instructions on how to complete. With REST, you can make a call to the URL, which makes it a little easier to work with. This code example shows a typical token request for admin. This example shows a token request for customers. Finally, this example is a token request for anonymous, all. See your course exercises guide for instructions on how to complete this exercise and its solution.